Hi everyone, welcome to another one of my philosophical lecture shorts. Today we are going to discuss chapter 5.3 of Hurley, the Concise Introduction to Logic. It's going to hopefully be a quick video. In the last two chapters we talked about categorical syllogisms, how to classify them. In the second section we use Venn diagrams to check for validity. In this one, after going through it, and you'll see through the exercise, there's some general rules that come up that you can also use to check for validity. And sometimes people like using the rules, some people like using the Venn diagrams. We're going to kind of hopefully understand all of it. And here are some of the rules that have to be the case for an argument to be valid. One of the first rules that you'll see is the middle term must be distributed in the argument. Now, if we go back here, I try to write it in, we'd have to go back to the first section. We discussed distribution. Excuse me, not the first chapter. Chapter 4, we discussed distribution. An A proposition always distributes the subject, so the S. The E distributes both of them. I distributes none of them. All right, and O distributes only the predicate. Okay, so go back to chapter 4. If you don't remember that, make sure you understand what distribution means. And all this is saying here is that it has to pass this rule for it to be valid. Actually, you'll see it has to pass all these rules for it to be valid. The middle term must be distributed at least once in the argument. And so let me give you an argument that doesn't do that. Let me write it here. So let's say we have an A, I, 2. So let's write this one out, A, I, 2. So I'm going to write it real quick. That would be all, all, there we go. Try this again. All P, R, M. And then we have all S, R, M, and then we have a conclusion of some S, R, P. So an argument like that. Now, we don't need a Venn diagram to tell us one because we go to this rule. The middle term must be distributed at least once. And so we see for an A proposition, only the subject is distributed, so the S and P are, but the middle term, where the predicate would be, is not distributed. So we would actually break this rule, and what that rule is called the undistributed middle. You broke the fallacy of an undistributed middle. And so you could say invalid, and you would write undistributed middle there, and I would know it broke that rule. It would be invalid. So there's one of the rules you can't break. Let's go kind of erase this. Let's look at a few other ones. Rule number 2, if the term is distributed in the conclusion, then it must be distributed in the premises. So it's saying this: if you have an argument at the conclusion has any of those terms, the minor or major term, are distributed in that one, then it has to be also distributed at some point in those premises. So let me give you an example here. We'll take an A, IA1. So an AIA1, which would be, let's try to write it out, all M, RP. Then we have some CS, RM, and then our conclusion would be all S, RP. And one of the first things we see here is at least it doesn't break the first rule, because all M right there, that's distributed, that's in the subject, so M's good. We look at rule number 2, say, okay, is any term distributed in the conclusion? Well, all S are P. The P we're fine, because that's undistributed, but the S, because the subjects of any A proposition are distributed, is distributed. So then we look at where the S is. Okay, it's here. Now we're looking, that's an I proposition, and we see that none is ever distributed there. So we see the S is not distributed, therefore it would be invalid. All right. So S is the minor term. So what we would call this, you had what we call an illicit minor. So you would distribute, you're not distributing your, your undistributed middle term, or an illicit minor. Okay. Let's go, if you were to reverse this and had, let's say the P was it, you would have an illicit major or undistributed major as your invalidity, why it's invalid. Okay, so let's look at rule number 3. This is the easiest rule. 2 negative premises aren't allowed. So if you ever get any argument that looks like EOA, you don't even need the figure here, or you get EOI, or OEA, or whatever you want. You can put anything at the end of these. Actually, these can be an E, that can be -2, doesn't matter. If you ever have 2 arguments that have an argument that has 2 negative premises, automatically invalid, excuse me. So you would just put broke rule 3, negative premise is not allowed. So you can't do that. Now let's say it passes all 3 of those tests. All right, then you would have rule number 4. which is a negative premise requires a negative conclusion, or vice versa. If you have an affirmative conclusion, then you need affirmative premises. What that means is this: if you ever get an argument that has a negative conclusion, like a negative premise, so it has an EA, and then let's say we have an I as our conclusion, which is a affirmative conclusion, we have a negative premise, that would break that rule right there, right? So if you have a negative premise, you must have a negative conclusion in it, okay? And it can't break the other three rules either. So anytime it breaks any of those rules, all right, it is invalid from the Boolean standpoint and also the Aristotelian standpoint. Now make sure you go in and check in the textbook, go through these rules here, because on the exam and all you see in the exercise, you're going to have to, sometimes use a Venn diagram to prove its invalidity, but sometimes they're going to ask you which rule did it break, and you're going to have to be able to tell me which rule of these it broke. Now, let's say it doesn't break any of these rules. There is a fifth rule that is called the existential fallacy. All right, rule number 5. The existential fallacy is you break it. I'm not drawing very well, but there's a fifth rule here, right? And that means you cannot draw a particular conclusion from two universal premises. All right, so you can never have two universal premises, either A or E, or AA, EE, AE, EA, whatever, and get a particular conclusion. That will be called the existential fallacy. You're assuming existence when you can't, under the Boolean terms. Now, if an argument doesn't break any of these 4 rules, and you have two universals and a particular conclusion, well, then you can say, what does Aristotle think? And then you have to look at what is the appropriate condition. Is it the S, the P, or the M, the major, the middle, or the minor term that's important for existing? And if that thing exists, then you might actually have a conditionally valid argument if it does exist. Now, the way to tell what's the important condition for an Aristotelian look at it, you can do a couple different things. You could look at the chart that we talked about in chapter 5.1. You could draw a Venn diagram, and it's the one area, if you looked in the last lecture video, the one area that isn't shaded. Or another way to look at it is whatever term is superfluously distributed. What that means is whatever term is distributed more than it needs to be to pass these rules. The one I like to use is draw a Venn diagram. That's the easiest, most time-tested, but it's up to you. Now, this was just a quick run-through. Make sure you look at chapter 5.3. It's an easy chapter, but it's going to go through a bunch of these different examples to show you all the ways you could break these rules. It'll give you the names of the actual fallacies that we have. And make sure you're ready for it, and take a look at the exercises. They'll help you before you take the quiz on chapter 5, and then eventually the exam on chapters 4 and 5. If you have any questions, please let me know. Thank you.